Hello, welcome everyone to this CNCF webinar. We are going to talk about untangling Kubernetes state management with Sveltos and k0rdent. My name is Prithviraj. I'm a CNCF ambassador, and I am glad to have of the amazing folks from the platform engineering community, Simon and Wahab. So, without any further ado, I would just move on to quick introductions. As I spoke about, I'm a CNCF ambassador. I am also working with the K0s and k0rdent community. I was working with chaos engineering and Litmus Chaos for the last 4.5 years, and it's been a lot of platform engineering, k0rdent, Sveltos, K0s lately. And I'm glad to be joined by two amazing folks.
You are. Thank you, Priti. Yeah, so my name is Simone Morellato, and I am one of the co-founders of Sveltos. I've been in the Kubernetes ecosystem now for more than 10 years. I was actually at the very first KubeCon in San Francisco, and then I only think I missed one or two, so I went to all of them. And I've worked in Kubernetes in many different companies, most recently at VMware with Tanzu, and now with Sveltos and Gianluca, building this great product that many companies are finding very useful. And just recently, I joined vCluster, and I'm leading their growth activities.
I'm Wahab Ali. I'm a software engineer at Mirantis currently. But I've been working in the industry for 10 plus years. And At Mirantis, I started off as a software developer developing Mirantis Secure Registry. And then In the past year or so, I moved on to k0rdent, which is a new product, open source project at Mirantis. And I've been focused on the state management part of k0rdent.
We'll talk more about it, but let's quickly look at the agenda we have in hand today. We are talking about multi-cluster platform engineering. I mean, platform engineering has been a very popular topic today. I still believe that the existence of platform engineering is not something that happened today, but exists since we are talking about building infrastructures, DevOps engineering, the congregation between developers and the ops side of things. Then building developer portals, how it's packaged today. So I believe it has existed for a very long time, but with the shift to Kubernetes, I think things have changed. We are more towards managing distributed systems, distributed architectures. So we call it platform engineering. We'll be talking about state management, which is where we introduce two amazing open source community projects, Sveltos and k0rdent. Simon will be talking about Sveltos, how you can get started, what are the main features, and run a quick demo. And Vaha will be talking about k0rdent, what's k0rdent all about, the architecture, and a quick demo on the state management. So let's start with a very quirky slide. I'll start off this webinar, what we are going to talk about. This is a slide which basically talks or showcases hello in 100 languages. And why do I bring up this slide is because developers who will possibly watch this webinar tomorrow, or any persona who watches this webinar tomorrow, will understand what is expected from them when they are asked to learn a similar image, which is this, the CNCF landscape. People are asked, I mean, not just developers, but everyone out there is expected to learn tooling that is beyond their comprehension. I mean, I can be a community manager, I can be a cloud native resiliency engineer, but I am expected to learn databases, application definition, CI/CD, a lot of different tooling in the software delivery or software lifecycle management ecosystem. And that is what created not just like we are not just dealing with the tool sprawl era, but we are also dealing with a developer mindset sprawl where developers are expected to learn different kinds of tooling, and developers don't want to do that. I mean, they want to be writing code, they want to be finishing off their tasks, they want to focus more on development rather than learning tooling, doing the ops side of things, doing testing, incident management. And that is what has created this need of serving a standardized approach, an approach towards building platforms and enhancing the developer experience, creating golden paths, moving away from the Kubernetes sprawl that this generation has seen. And if I have to talk about that, I mean, this has existed since the beginning of cloud itself. The idea of cloud was to make things simpler, a data center interacting with a public cloud environment. But this is the eventual reality that we have served with. There are multi-cloud environments, hybrid cloud environments, OpenShift, VMs, bare metal, edge environments. I mean, companies, enterprises, teams are hosting their environments in different environments. I mean, I think someone spoke about vCluster. People are also moving towards virtual Kubernetes, but that shift in itself isn't really like a completed shift. I mean, people still are slow. I know a lot of enterprises, banks who are still moving from legacy architectures. So there isn't just a legacy approach, but I think even microservices, the microservices movement has seen a legacy approach, and that is where Kubernetes became that one orchestrator, powerful scheduler that tried to make things simpler. I mean, we had Docker Swarm, Mesos, but we believed that Kubernetes is the one orchestrator that is going to make things simpler during the containerization movement. But this is the reality. I mean, Kubernetes has matured, but still we are seeing the heavy amount of APIs under the hood. I mean, each provider in itself has a Kubernetes provider. I mean, we have a GKE or an EKS or an AKS, or people are hosting their private cloud environments with Kubernetes under the hood. But still, we haven't reached that mindset or that era where you have like folks have matured their Kubernetes usage in itself, or we are using Kubernetes as the common control plane, the common source of truth to manage these environments. And that is where I believe that platform engineering needs a shift. Platform engineering needs to find, I mean, I know there are a lot of tools out there, enterprise solutions, DIY solutions. There is Cluster API, which is basically helping you manage your environments, different clusters. But I still believe that I mean, this mindset needs a shift. Just like we have had a shift left mindset for testing, there has to be a sort of mindset where you are able to move towards considering platform engineering for the right reasons. It's I mean, these are the top reasons which the community believes is why platform engineering needs to be considered, and I have, I mean, utmost regard for that. I mean, production releases are happening every month. Folk people are wanting to accelerate their cloud native journey. I mean, resources are costly, tasks have been manual, up to date. People want to move to an automated way of going about things. I mean, GitOps has matured, CI/CD practices have matured. Of course, there are a lot of incidents that are happening. Outages are critical. I mean, integration testing, performance testing, chaos engineering, incident management are becoming a norm today. Consistency is key. You need to ensure that you're managing each and every pipeline, each and every cluster, I mean, each and every infrastructure at a node level, at a pod level, at a cluster level. So the idea is to standardize this approach and ensure that this I mean, the idea behind standardizing this, building the right developer portal with the right tools, comes into not just like as a practice amongst the community or amongst developers, but as it follows a multi-level approach where your decision makers are behind it, your SREs, your developers, different, I mean, mindsets, even your customers. So it's not just the producers who are having this mindset, but also the consumers, which makes platform engineering democratic and drives it for the real tomorrow. And to be honest, I mean, platform engineering requires scale. You have to ensure that you are able to manage your platforms in the right way. There's not a tooling sprawl or a services sprawl where you are, say, trying to add new services. Say you're trying to add an ingress controller, a new database, you're trying to add security testing orchestration or your resource optimization. A lot of folks are moving towards cloud cost optimization. So you need to ensure with the demand, with platforms or the architectures being dynamic and new services getting added every day in or day out, they have to be managed. There's no outages. Again, improvable. You're getting the right insights. You are improving your architectures as you move ahead. You're adding the right services. Observable, again, I mean, I believe today platform engineering cannot go ahead if you're not observing what's happening in the system, the right insights, you're monitoring, you're logging, you're tracing, bringing everything in place and improving your systems as they go ahead. Controllable, of course. You need to ensure that your outages are controlled, you're using the right testing, the right resilience in place, so that even if something goes wrong in the system, because it's not about how, but it's about when, because eventually there is an outage that might possibly happen, if not today, tomorrow. So you need to ensure that your systems have the right rollback mechanism, the right root cause analysis, anomaly detection mechanism, and they have to perform eventually. I mean, the idea is to ensure that it is simplifying tasks for your teams. It is simplifying what DevOps perhaps couldn't, in spite of being in spite of trying to make things simpler for the developers. Platform engineering became a concept where platforms will be shipped to developers, so they have to perform and ensure that different developer teams, even if they are using multi-tenant architectures, air-gapped environments, they are able to run their platforms at scale. And multi-cluster, multi-cloud is the norm. We spoke about how, I mean, I know so many folks who, I was recently talking to this telecom company, and they spoke about how they have companies within the company, so micro companies within their larger ecosystem, which where, say one team is hosting their environments on bare metal, the other team has a GCP environment, but the third team is completely on AWS. And that is where bringing all of them together needs a norm, needs the right state management, cluster management, cloud cost optimization, everything in place. And that is where we talk about the challenges of multi-cluster platform engineering and why Kubernetes state management is essential in today's ecosystem. So the best practice, of course, is having a single application per cluster, multiple infrastructure providers, or dynamic on-demand clusters. So whenever there are any changes that are supposed to happen, they are time bound or scheduled in a certain way, services are running in series or parallel. You need to ensure that your clusters are in the right place. And but that's not what the reality is. I mean, how you perceive things and how they eventually happen are pretty different. The challenge today is workloads are inconsistent. You don't have the right policies in place. Even if you are implementing, say, Kyverno or OPA, you don't have the policies in place. Operations are complex, and Kubernetes sprawl is the reality. Even if you're trying to implement all the different tooling that I took you through while I showcased the Kubernetes or the CNCF landscape, there is a Kubernetes sprawl, and there's no right way of performing multi-cluster platform engineering. And that is where I feel state management or service management becomes essential. I mean, I mean, I know that Kubernetes implementation has been vital, and most of the organizations today, I think around 75%, according to one of these surveys recently by the CNCF, suggests that 75% of the organizations have moved to Kubernetes. But while they try to mitigate this multi-cluster platform engineering challenge, there are a lot of more challenges that come up with state management or managing your add-ons to your Kubernetes service or your life cycle itself. And that is where I will like a little bit more emphasis on Kubernetes state management, because that is where we will introduce Sveltos or k0rdent. The idea is to ensure that you are deploying, maintaining, scaling different tooling while ensuring that you have your Kubernetes provision, your Kubernetes deployment provision. But when you are trying to, say, add on a management service, say an ingress controller, a MongoDB service, you are able to manage the state of your environment as well. And that is where you say, you are able to have, you're exposing your service, say a set of pods, and abstracting an ephemeral nature of your pod IPs. Say your service types are exposed because Kubernetes offers different services, your cluster IP, your node port, your load balancers. And that is where you need to ensure that you are able to manage the life cycle of these services as well. And that's how, I believe Sveltos has become an important community tool. The k0rdent State Manager has become an important community tool. And I'm glad that, we have tooling out there which are growing in the community and seeing state management as essential. I know there are enterprise providers, say Rancher, DigitalOcean, which have a state manager in place, but I don't think they match up with what a community centric solution is. And that's why I'm glad to have again Simon, who will talk about Sveltos next. So Simon, let's get started. Let's introduce Sveltos to the community. I think you're on mute, Simon.
Oh, actually, I was. Can I share my screen since I have a bunch of animations?
Absolutely.
All right, so let's share. Slideshow. All right, so here, hopefully, Sveltos is going to solve some of the issues that Privid mentioned, and that's kind of the idea. We really focus on add-on management for Kubernetes clusters, especially for folks that are managing multiple Kubernetes clusters. Because if you have one cluster, you can kind of get by, you can kind of make sense. But when you're managing tens, 20, hundreds of clusters, it starts becoming really complicated. So a quick overview of Sveltos. As I said, we really focus on managing multiple Kubernetes clusters, and we can manage the clusters anywhere, like no matter if they are on Amazon EKS, Azure EKS, Evo, GKE. We do something special for clusters that are managed by Cluster API. And then we also do work with virtual clusters, like I pretty mentioned at the beginning. There's so many different type of clusters. But the idea is pretty simple. Like most of the industry is actually evolving on having a management cluster where you run all your management services. And that management cluster is going to manage all the managed clusters. So Svelto works with a simple CRD and cluster profile definition where you define what you want to do with these managed clusters. And I'm going to show you now a quick demo or a quick animation to really understand how it works. But before we go there, let's look at the cluster profile and see what you can do and how you specify which type of add-ons will go into different clusters. So the idea is pretty simple. You will label clusters with a label, like in this case, environment equal production. So you might say, for all the clusters that are labeled production, I want to deploy an Helm chart. In this case, I want to deploy k0rdent. And I want to deploy some config map or secrets. So as you can see, this is a simple configuration file, YAML. It can become much bigger if you are deploying multiple Helm charts and multiple secrets and multiple config maps. You can also do customization with Customize. But at the essence, it's very simple. You just define your labels and you define what you want to deploy in the cluster. So for example, here, there could be an organization that have environment for development and environment for production. So how will it look like? You will create two cluster profiles, one for development, as you can see here on the left, where I'm saying I want to deploy Contour. So all the clusters that are going to be labeling development are going to get Contour deployed. And then I create another cluster profile where I say now environment production. And for environment production, now on top of Contour, I also want to deploy k0rdent. So it's simple, like listing one after another, the different add-ons that I want to add to the cluster. And so it's simple, like you don't have to change, use a different CLI or anything. It's your typical familiar Kubernetes CLI kubectl, and you just do kubectl apply -f and the configuration files for Sveltos. Sveltos is going to take it, it's going to look at the different clusters, look at the labels, and based on the label, it's going to deploy the different add-ons. So how does it work in practice? So I have my Sveltos that is installed in my management cluster. And specifically in this case, if the cluster has cluster API, I don't need to do anything for the workload cluster. Sveltos automatically detects every time there is a new workload cluster that comes up, it knows where it is and it can actually access it. But Sveltos also work with clusters that are not managed by cluster API. You just need to do a quick registration on the clusters to be able to be managed by Sveltos. So as a DevOps administrator, I'm going to go and apply my configuration. Here I'm telling, look for the environment production, deploy k0rdent. So if I go and I change the label to my first cluster and I say production, Sveltos is going to detect it and it's going to go and deploy k0rdent. Now I can go to the second cluster and also going to do the same, add another label, say production. Sveltos is going to detect that also this cluster now has a label production, and it's going to go and deploy k0rdent. So pretty simple the way it works. Now you will say, oh, what happened if I remove the label? Sveltos is going to go and detect that somebody removed the label. So that means that k0rdent is not needed, and it's going to go and remove it. So by adding and removing labels, you can make your cluster management much more dynamic. Now, let's say how Svelto works with configuration drift. So let's say, for example, starting from the beginning, I configure now this mode as configure continuous with drift detection. That means that Sveltos is always looking at your workload clusters, and something happens, is going to reconcile. So what can happen, for example? So let's first deploy a new label. In this case, I'm using FV. So Svelto looks at this new label, and same case as before. The cluster profile say that we need to install k0rdent. It's going to install k0rdent on the cluster. But since I configure continuous with drift detection, Sveltos also has an agent running on the workload cluster. And the agent is looking for configuration drift. So now, if a user, I go and do the same for the second cluster, I'm going to look at the label, deploy k0rdent, and everything is fine. But now let's say a user comes in my workload cluster and decides that he doesn't want to use k0rdent. He doesn't like the policy, he wants to delete it because he wants to do whatever he wants. Sveltos is going to detect that k0rdent was removed by the user, but this is actually a drift. The operator didn't want the user to remove k0rdent. So the Svelto agent is going to talk to Svelto and say, hey, Svelto, somebody remove k0rdent, do something. Svelto's going to like, oh, yeah, that's true. There is no k0rdent anymore, and it will reinstall k0rdent. So this is a way for you to ensure that the clusters are always configured with the add-ons that you need, and nobody can go and tamper. Of course, I mean, this is also the default behavior, but let's say in a case where you are setting up the clusters and you are disconnecting them from Sveltos to give it to somebody else, and they will take care of management. In that case, you can say, don't do configuration detection. Just leave the cluster the way it is. That's the behavior that I wanted. So it's very configurable. There are some defaults, but the default can be edited based on your preferences. There's a lot more features that I don't have time to go into details, but Sveltos provided dry run. So as you saw, it doesn't automatically go and change your cluster configuration. You can say, do a dry run before, so I can verify to make sure I really want that change to happen. It can do rolling upgrades for deployments, default sets and demo sets. It has a powerful event framework. So Sveltos not only is static, so where I go to the profile and they decide what needs to be installed. It can also look at the environment. It can look at the API in the Kubernetes clusters, or it can use integration with the messaging system like NATS. And based on events, it can do things to your clusters. So for example, you can set up Sveltos to look for new users to be created in your organization. And if the new user gets created, Sveltos automatically can deploy the right add-ons to the cluster. You can do fancy templating, you can do tiering for conflict resolutions. So for example, you might need an add-on to be deployed before another add-on or after another add-on. So all of this can be specified. You can say first deploy contour, then deploy k0rdent, then go and configure the secrets. All of these things can be configured properly with Sveltos. It works in push and pull mode. And so essentially that means that you can give access to Sveltos directly to your Kubernetes cluster, so you can manage it with direct connectivity. Or if your clusters are behind a firewall or behind some NATs, you can use pull mode. So then the configuration, instead of be push from Sveltos to the managed cluster, is going to be pulled from the agents that you saw before from Sveltos that is running on the management cluster. So it can go to a firewall. It can do things like monitoring. If you're running large number of clusters, like over 100, you can do sharding, so to make it a lot more efficiency. And you can, with multi-tenancy support, you can have multiple organizations actually sharing the same Sveltos process. One of the latest features that we just added last week was an MCP server and an MCP client. So now if you're in your organization, you're running like AI SREs, so those tools that automatically go and with AI discover issues and resolve problems in your Kubernetes cluster, they can also talk to Sveltos through the MCP server. And then another feature that people are using quite a bit is the tech support. Let's suppose you are a service providers that are offering Kubernetes clusters as a service, and something happens on one of your users, you can run the tech support to collect all the logs from the managed cluster and be pushed into the management cluster to see what's wrong with that user that was reporting an error. How do I get started? Actually, it's pretty easy, and that's what I'm going to be my demo about. It's really one command to install Sveltos in your Kubernetes cluster, and another command to install the UI. So let me quickly jump out of here and share. Where is my Zoom now? Let me share again my terminal. All right, so here you go. I hope you can see my terminal. So I'm actually running Docker Desktop and enable Kubernetes on my laptop. So I'm going to use my laptop as my machine to run Kubernetes. And as you can see, I already ran the command kubectl gets nodes. So Docker Desktop is still running. I have my Kubernetes control plane. So the first thing I'm going to do, I don't want to run Svelto directly on my Docker Desktop Kubernetes cluster, because this is probably something that everybody should not do, run everything and do demo in their own cluster. So what you can do is actually create a virtual cluster. I I wrote a tutorial. I can share it later for the community, how to create virtual clusters and how to register with Sveltos. But I use it for demo purposes. So first I'm going to create my virtual cluster. That only takes a minute. So now what vCluster is doing is creating a virtual cluster inside my real Kubernetes cluster, essentially taking the API server, control manager, and running them as a pod. So now, after I'm done with my Sveltos demo, I can simply delete my virtual cluster, and I have my clean host cluster without any demo, or if I do any mistakes or anything, my host cluster is always nice and clean. So just give it a minute. While this one is doing, I'm going to go and look for the command to install Sveltos, deploy Sveltos. Here it is. And update. The cluster was completely empty, so it's going to install Sveltos from the beginning, and it's done it. So now Sveltos is already up and running. Next thing I want to do, I want to deploy the dashboard so we can actually see a little bit about what Sveltos looks like instead of looking at the CLI. So it's another command to run the dashboard, and that is done. And now I'm going to port forward my dashboard to the port 8080 so I can actually open it. All right, so now I can open it here on my localhost, and I have the UI. Next thing I need to do, I just need to create a platform admin for my Sveltos. Actually, I need to do it here because they're in port forwarding. Platform is created. I'm going to create a role binding. Here you go. And one last thing, I'm going to create my token so I can access it. So now I can just take this token, put it in the UI. And here you go. Sveltos is nice and running. This is my management cluster. And now I didn't deploy anything, so it's all empty. Here is my MCP client, and it's also telling me that Sveltos is running perfectly. And with that, now what I can do is actually I can register a cluster to Sveltos. So I don't want to spend time here in creating an extra cluster. So what I'm going to do, I'm just going to register the management cluster as a managed cluster. So you can do that too. I'm going to apply the configuration. And now if I go back and look at the dashboard and refresh, now I have my vCluster here being managed by Sveltos. And I think with that, one more thing that I can do, I can quickly show you a couple of things to get started. Now you know that it's super easy to install Sveltos, install the UI, and register a cluster. You can find out more resources on GitHub, or if you go to the LinkedIn page, we always post blogs about new features of Sveltos or our company are using Sveltos, or you can go to the website where I try to keep all the links to the most important resources that you need. With that, I can pass the ball back to Wahab that is going to show us how he actually is using Sveltos inside k0rdent and make it even more powerful.
So,
Sure.
Simon, before we move to Wahab, I just had one question for you, maybe which we couldn't cover.
Sure.
And I mean, I could have had many questions, and I honestly believe that the UI looks good. The way the MCP server has come up and making the AI way of managing workloads, that also looks pretty interesting. But what's next for Sveltos, if I may ask? Like moving ahead, we might be having a community roadmap for the tool, and there are a lot of things that are growing. So just wanted to understand what's next for Sveltos in terms of roadmap.
Yeah, that's a good question. Actually, we're like heads down working on this MCP server and integration with AI. So we really didn't. I need to check with Gianluca, that is the main developer, and see what customers are asking. But yeah, there's always like many questions coming in and feature requests from users. But I think we're going to double down on making Sveltos even more easy to use and be able to manage even more clusters. We have customers that are really pushing Sveltos to the order of 200 plus clusters. And that's kind of good because we just see them testing in production. We actually don't have a lab that is so big to be able to test it. So it's good to know that they're using it and it works. But now feature like sharding came up from this type of use cases, and I'm sure there's more. I'd be happy to maybe share some information after I chat with Gianluca on what's next.
Absolutely, absolutely. Thank you so much, Simon, and glad to know that more and more customers and end users are testing Sveltos in production, 200 clusters and more. So yeah, we look forward to a roadmap from Simon and perhaps add it to the webinar or to the community. But yeah, Wahab, let's introduce k0rdent State Management, how Sveltos has empowered the tool. Wahab, the floor is yours.
Thank you, Prithvi. Yeah, so let me start sharing my screen. Okay, so k0rdent. k0rdent, we can consider k0rdent as a super control plane of sorts, which can manage other control planes. In the context of this webinar, you can think of the difference between something like Sveltos and k0rdent would be that Sveltos manages the state of your Kubernetes clusters, and with k0rdent, it builds on top of Sveltos, and it can provision clusters, different flavors of clusters on different platforms, and then it can use Sveltos or any other provider for state management to manage those clusters as well. So one of the key focuses of k0rdent has always been to manage these clusters centrally in a template-driven fashion, so that we can have a consistent, repeatable way to manage these clusters, which just makes it easier for developers and platform engineers to manage these huge sets of clusters. So before I go into detail for k0rdent state management, I'll give an overview of the components that k0rdent has. So basically, k0rdent is composed of these three big components. The first one is called the k0rdent Cluster Manager, KCM. This is the portion of k0rdent that is responsible for lifecycle management of clusters, creating clusters, deleting clusters, upgrading clusters, etc. Then we have the k0rdent State Manager, KSM, as we call it. And this is the part of k0rdent that's responsible for managing the state within a cluster or within a set of clusters. And it does so with Sveltos. So we install Sveltos with k0rdent as a provider for state management. And that's what's being used under the hood right now. And then we have k0rdent observability and FinOps, and this part of k0rdent is responsible for observability, logging, cost management, all of that stuff, which is very important for big customer teams, big platform teams, and enterprises. What the Sveltos dashboard that we saw, that is also been included as part of k0rdent observability and FinOps, along with some other dashboards as well. So you get that bundled into k0rdent. So this is a high-level overview of k0rdent with these different components of k0rdent that we just talked about: the observability part, the state management, and of course the cluster management, which comes at the very bottom, provisioning the clusters and so on. And of course we have different providers, infrastructure providers, so you can manage these clusters on public clouds, on premises, or any combination that you can choose. So before we go into, so now we'll be focusing more on the k0rdent state management part of k0rdent. So one of the things that k0rdent has is a template system, and I want to give a brief introduction to this template system before we move on to a demo and where you can see this playing out. So we have three main templates. The first one we call a provider template. This is the template that installs the different providers that k0rdent uses. So CAPI provider for AWS, for example, CAPI provider for OpenStack, Cosmotron, and even Sveltos. So Sveltos is installed as a provider using this provider template. And then we have a cluster template. With this template, you can define what the configuration of a cluster should be that you want, and on which platform do you want it, which flavor of cluster, so to speak. So you can have an AWS EC2 cluster, an AWS EKS cluster, etc. And you can define how many worker nodes do you want on it, how many control plane nodes, and things like that. And then finally, we have the service template, and these are services that you want to install onto whatever clusters that you're managing with k0rdent. So this is so services in k0rdent is analogous to add-ons that we discussed in Sveltos. So basically meaning that whatever application you want to deploy onto your clusters. So here is an example of some of these templates. So when you install k0rdent, you get by default these provider templates pre-installed, and these cluster templates pre-installed as well. So you can see we have so k0rdent is using cluster API CAPI to provision these clusters. So you have the provider for AWS, Azure, etc. All of these, and then you have KCM, which is the main controller, which for k0rdent, which has it's named KCM right now, but it is packaging both KCM and KSM. We are in the works of separating out KSM into a separate binary, but for now, so the KCM part of k0rdent is installed as a provider itself, and then of course Project Sveltos is installed as a provider as well. And here we have the cluster templates. So if you can see the cluster templates, for example, you have AWS EKS. So you'll use this cluster template to create a cluster on EKS. And if you want a cluster on EC2, AWS EC2, you can use AWS standalone template. So just in a moment, we'll see how we use these templates to provision a cluster and install services on these clusters using these service templates. So you have a cert manager, different versions of Nginx, k0rdent, etc. So before I go on to the demo, I want to show an example of a service template. So here I have service templates. So let's look at a service template Nginx 4115. So if you look at this object, so all of this stuff is basically Helm values that is printed out in the status of the object. This is the main portion that we're interested in, the spec. So this service template, as you can see, is referring to a Helm chart. And this Helm chart is getting fetched from a Flux Helm repository source. So we're also using Flux in the background to power these templates. So you can use any Flux source with these templates. Over here, we're using a Helm repository and a Helm chart. But if I look at another example, service template, if I look at this Hello World service template that we have, so with this template, you can see that we're using a customization. So there's the URL for where the customization files are and the path. So, and this is also so like this, you can have multiple backends for the service templates as well. So just wanted to show that just like with Sveltos, you can have multiple, you're not just limited to Helm. So, okay, so let's go back to the slides. So we have a website called k0rdent Catalog. So this is a curated list of these templates you can find on there. And so I'll just open up this website, and we'll install let's say we want to install Cert Manager. So we go to Cert Manager, and we can see it gives you the instructions to install the Cert Manager, and even how to use the Cert Manager in to provision onto a cluster. We'll see that later on. So let's first just install the Cert Manager. So we just copy this Helm install command, and so this is where my the k0rdent management cluster or mothership cluster is. So if you see, we have all of these controllers running on the mothership cluster, the KCM controllers over here, the CAPI controllers, and the Sveltos controllers as well. So let's install the Cert Manager service template on our mothership cluster. So we run this command that we copied from k0rdent catalog, and we get service templates. So we'll just wait for it to reconcile, and we'll wait for it to become valid true. Here you go. So it's simple. It's very simple to install these service templates, and the k0rdent catalog is a good resource where you can find most of the popular applications that one would use with k0rdent with the Kubernetes clusters. So moving back to the slides. Okay, so now this slide, we're presenting some of the decisions that actually some of the research that we did before we chose Sveltos for state management part of k0rdent. So these are the different projects that were considered, and this is not an exhaustive list, but this is some of the key points that were considered. So, for example, k0rdent, we intended to use CAPI, so it was very convenient to use a project for state management that would auto discover CAPI clusters. So Sveltos had that capability, and then Sveltos k0rdent we're focusing on a way of doing things where we have a management cluster or a mothership cluster, so a centralized place where you can manage your other Kubernetes clusters. Sveltos also fits in very well with that paradigm. Sveltos is multi-tenancy capable. That's also something that was important to us with different platform teams and platform engineers and developers and all of these roles. And then one of the things that was also important from a business standpoint was the ability of customer platform teams to have GitOps knowledge. So, we wanted something where we wouldn't be pigeoning them into, working with GitOps. So Sveltos had that capability, for example, with FluxCD, we were very, we just had to adopt the GitOps workflow. So, and then work needed to implement Sveltos, which was also easier because all we had to do was to just create and manage the lifecycle of Sveltos objects, CRDs, and basically install Sveltos when you install k0rdent by default. So it was easier to install than some of the other projects where we had to maybe do some more development work to fit them into the vision that we were looking for state management. Okay, so now let's go to a demo. So with this demo, I already have 2 clusters deployed, one on AWS and one on OpenStack, and I have Nginx deployed on both of them. So what I'll do is I'll upgrade Nginx to a newer version of Nginx using a k0rdent CRD called multi-cluster service, and and in the background of all of this, Sveltos is actually doing the upgrade part, the state management part, and k0rdent is orchestrating all of this. So let's just go to the demo, and I'll introduce the k0rdent related CRDs as well. So if you look at, so we have both of these clusters deployed right now. So let's look at the YAML for how these clusters were created. So we have a custom resource definition called cluster deployment in k0rdent. So this is the YAML definition that will deploy a cluster for you. And in the spec, so you see this template. This is the cluster template that we use to basically tell KCM which flavor of a cluster we want. So for here, it's AWS standalone. So this will deploy this cluster on AWS EC2. And then the config has all of the configuration related to AWS that you need. And all of this information can be found on k0rdent documentation, where you have pages dedicated to how to set up a cluster deployment on AWS, on OpenStack, and all of these providers. So for example, over here, we want one control plane node and one worker node, the AMI of these nodes, what instance type we want, D3 small in this case, etc. So this is up till here was all of the configuration for setting up a cluster using CAPI. And then here we are interested in here is where the KSM part comes in. So we have service spec, and we're using Project Sveltos as the provider. So we specify that, provider, we want to use Project Sveltos. So this provider with this name should already be installed, which is installed by default when you install k0rdent. And then we say, okay, we want to deploy these services on there. So this template is actually a service template, which we saw before. So if I look at service templates, so the Nginx 4115, this is a template we want, the name of the deployment and the target namespace. And similarly, if we go to our OpenStack cluster, the same thing. The only difference is that the template we're using is one for OpenStack. The configuration is OpenStack specific, and the same provider using Project Sveltos and installing the same Nginx service on OpenStack as well. So so if you look at these, so this the blue screen here is showing the AWS cluster. So if you look at the cluster, we see Nginx installed and AWS Cloud Controllers installed over here. And this green screen is for the OpenStack cluster. So again, look at what's installed over here. So we see Nginx installed over here, and Calico and other OpenStack related controllers. So what we're going to do right now is we have Nginx installed. So what we're going to do is use this CRD called multi-cluster service. As the name suggests, you can define a service in this YAML, and it will apply to all of the clusters which match this label, just as we saw when during the Sveltos demonstration. So what we want to do with this service is we want to upgrade Nginx to 4113. But we have a priority of 2000. This can be any arbitrary number from 0 to however large number the language runtime would support. So with 2000 over here, AWS is 1000 and OpenStack is 3000. So the higher the number, the more the priority. So what will happen in this case is that the multi-cluster service will successfully upgrade Nginx on the cluster that has the lower priority, which is the AWS one, but it won't be able to upgrade on the cluster that has the higher priority. So this is just one of the use cases that I want to show. So let's do that. So let's apply multi-cluster service. So here it is. Now, if we look at what's happening, so we'll get the cluster deployments again. And so it'll take a while to get. Here you go. So the service set, this is another k0rdent CRD, which we use in the background. It's similar to how Kubernetes deployments use replica sets in the background. So users usually won't have to deal with service set, but this shows that these new service sets were created right now by the multi-cluster service for each of the clusters. So let's look at the source. Okay, so here we see that now one by two of services are deployed. So this ready false, this is actually a bug right now. We're working on it, but as actually the service has been deployed. Let me just show you how it looks. So if you look at AWS, what it says is that the 4115 version of Nginx, this it failed to deploy this version because with the multi-cluster service, we wanted to upgrade it to 4113. So 4113 is deployed, it says, and 4115 has a conflict. And this conflict message is coming from our state management provider, which is Sveltos in this case. And if you look at the OpenStack cluster, which is Walidev2, over here we see the opposite. We see the because this OpenStack cluster had a higher priority, so we see the original version of Nginx still deployed, and the new version that the multi-cluster service was trying to deploy, it failed. So now if you look back at over here, this is the AWS. So we expect that the service Nginx service over here would have been upgraded. So if we just look at I guess this is the easier way to do it. Get deployment Nginx, and if we just grab the image of it. So we see it upgraded to version 113, and OpenStack, this should remain at the older version because it had a higher priority. So I'll just copy and paste this command over there as well. So here you see it's still the older version of Nginx. So with this demo, we just showed how cluster templates and service templates come together in just one YAML, where you can just easily customize which flavor of cluster you want and which services you want on that cluster, and you can use a multi-cluster service to manage multiple clusters at the same time. I just want to show one more thing. So we did deploy cert manager before the service template. So this is just an example of how you can specify some Helm values if you want with whichever service template you're using. So if we install cert manager over here, just apply. So now we should see on our mothership cluster, if you look at, so we see three services being deployed on OpenStack. So if you look at OpenStack, so we should see the cert manager being deployed. So if you look at the status of it. So Cert Manager is provisioning right now. So after a while, it'll be provisioned, and then we'll see some Cert Manager related pods running over here. So anyways, maybe it'll take a while to reconcile because I'm running this on a VPN, the OpenStack cluster. So this is the demo which with k0rdent and Sveltos working together. So now that we've seen the demo, maybe this architecture will be much easier to understand. So we have over here just shows that we have a KCM controller, which has the cluster management and the state management part bundled into one binary right now. And it just, when you create a cluster deployment, which uses a cluster template and a service template, the KCM controller will recognize that, and it will use create CAPI objects. So CAPI controller takes over, and whichever other providers that we have to provision those clusters, and then the KCM controller also creates the objects related to state management, which is Sveltos in this case. So it will create Sveltos profiles, cluster profiles, etc. And then Sveltos controller takes over and manages the state. And the KCM controller is orchestrating on top of all of these providers to provide a consistent experience and view of what's happening. So just a high-level overview of the KSM architecture itself. The previous slide was a k0rdent architecture. So with KSM, when you use a service template with a cluster deployment or a multi-cluster service, the controller, the KCM controller in this case, it creates an intermediate object, which was the service set object that we saw. Is similar to replica set with deployments. And then with this, what this enables us to do is then it enables us to plug in different providers for state management. So right now we have Sveltos as the state management provider. So it will so the intermediate object will create Sveltos profiles. If we for example, if somebody wants to use Argo CD instead, so we can plug in Argo CD, and the state management will then use Argo CD for managing the state of the clusters. So that's the KSM architecture. And just as Simone said earlier, I couldn't demonstrate all of the features of k0rdent and KSM as well. So I'll just give a summary of what are other things that we have. So for example, similar to service templates, we have service template chains. So as the name suggests, this is a CRD, an object which will have a chain of service templates. And using this chain, we can do a number of things. For example, we can have enforceable upgrade paths. So you'll be only able to upgrade the services to the versions that are defined by the chain. Similarly, we can have automated upgrades as well. So you create a cluster, you provide it with a service template chain, and the controller, the KSM controller will automatically go through all of the upgrades in sequential order. So you can opt into that as well. So that eases some of the management of these clusters, which is this feature is in progress right now. So we also have access control and distribution of these templates. So if you are a platform lead and you define a service templates in a namespace that's dedicated to the platform lead, and you want to make those service templates available to other teams, let's say, who are using other namespaces. So we have something called an access management CRD, which does this work of propagating these templates across namespaces. And then, of course, just as Sveltos, we have inter-service dependencies within the same cluster or within different multi-cluster services as well. So within a cluster, if you define service A, service B, service C, you can say service C depends on service B, it depends on service A, things like that. And yeah, more features as well, which we're currently developing, and with time, we'll hopefully get more useful features as well. So that's my presentation for k0rdent. I'll give it back to Prithvi.
Bob, do you have any resources to share with the community folks?
So finally, we have this resources slide as well. Kind of forgot about this slide. So yeah, we have a GitHub project, k0rdent. This has all of the repositories within it, the ones for KCM, KSM, KOF, etc. And then the docs for k0rdent. So if you want to use k0rdent with any of the providers, if you want to use it on AWS, Azure, OpenStack, etc. With these docs, you can find the relevant page, and it will guide you through all of the process, how to create the credentials for each of these providers, how to create the relevant objects in Cordant and so on. So yeah, that's the demo.
Thank you so much. Wow, I think that was a lot to take for the community. A lot of things, a lot of interesting items, a lot of things with Sveltos. But I think I'll ask you the same question as I asked Simon. What's next for the Coordinate State Manager? Where does the roadmap lie in terms of the community, and what's the community wanting, or where are we heading with the state management side of things for Coordinate?
So there's so as I like mentioned in over here, some of the things we're in progress. So that's what we can expect in the near future. And then we're also going to like currently state management is bundled into Cordant controller, Cordant cluster manager. So we want to separate that out so it's easier to develop for and to just support. And then we also, so this feature over here where we introduce the intermediate object. And so this is a relatively new feature. So what we're hoping with this feature is that people can create their own basically providers for Cordon State Management. So currently we bundle in Sveltos. So if a company or some organization wants to adapt Argo CD to work with a Cordon State Manager, so they can do that independently of by themselves. So they can write the basically they can write what the interface. We have an interface in the code, so they can just implement that interface and they can have their own provider as well. So that's something that we got recently. With these items, I think we have a lot of work to do in the near future. So hoping to get all of this into community's hands, and hopefully with if people just use it on huge sets of clusters, like Simone mentioned, that'll just be very great for us as well, and it'll probably iron out some of the things that we missed perhaps.
Awesome, awesome. Thank you so much, Wahab. That's like a lot of information, a lot of things for the community. I think we have had almost an hour and a half of information, a lot of details on Cordant, Sveltos, how to get started, the MCP server that Sveltos is building, a lot on the I think state management aspect for Cordant. I believe Wahab also covered a lot in his demo and what's coming up in terms of multi-cluster services and inter-service dependencies. So I'll want to conclude this webinar, but any last thoughts from Simon and Wahab? Simon will go first. Any final thoughts?
Yeah, so I was actually able to talk to Gianluca live as Wapap was doing the demo. And what's next for Sveltos is really something cool that is coordinating deployments across stages. So a user will be able to say, I want to deploy this set of add-ons into staging, and then I want to promote them to the pre-production environment, and then I want to do another promotion to production. So this moving add-ons from stage to stages is what's going to be coming next, our next big feature.
Awesome, awesome. That's big. And thank you so much, Gianluca, for pitching in between and sharing it with the community. What's next with Sveltos? I believe this is something to look forward to. And I hope, again, these users of Sveltos, folks who possibly will use Sveltos, post this, stay tuned and follow the community roadmap. Wahab, any last words from your side?
Just that looking forward to having more providers added on to the state management part of Cordon, so that it becomes more usable or adapts to more of the situations that people want. And we'll maybe in the future in the roadmap we might add some more providers ourselves as well, but it's always open. It's an open source project, so anybody can take up and add more providers as well.
All right, folks, with this, we come to the end of this CNCF webinar. It's a lot of information. We've talked about multi-cluster management, what's driving platform engineering. And I believe that's the reality which people correlate to. I just tried to make it a little simpler. And yeah, that's the reality. Simon spoke a lot about Sveltos, what's coming up, and interesting features where Gianluca pitched in as well. A lot of things happening with their MCP server. Vab spoke about k0rdent, what's it about, the architecture, and a brief demo on how the state manager functions. So feel free to ask any questions you have. Join the Sveltos community, join them and ask your questions. Join the k0rdent community on the CNCF Slack and ask your questions, or drop your comments in this video on the CNCF YouTube channel, and I believe someone from the Sveltos or the k0rdent community will respond. So thank you so much, folks. Again, I think a lot of information that we missed out on. I think Simon and Wahab spoke about that they couldn't cover the other features, but hopefully we'll have a part two to it according to the response. And yeah, see you everyone. Thank you so much. Thanks a lot.